Right, so in this video, I'm going to show you how I made this hot water heating tank for my greenhouse in-floor heating being heated with solar panels. Right, so this is my next project. My plan with this is I'm making an aluminum tank. It's going to hold water. I'm going to have a couple welded bungs in there to thread in hot water heating element. It's going to be heated by solar panels and then circulated through the floor of my greenhouse. Greenhouse has a concrete floor with in-floor heating, and this is my plan, try to get a few more months out of the growing season. And it's kind of like a little experiment for me to see how well solar panels can heat hot water. So what I gotta do is pull this in. I'm gonna do a little lap joint on this instead of a butt joint, whatever, and weld this up. I'm gonna put a bottom on it, and I'm gonna leave the top until I get the welded bunks because I don't have them yet. So I got this bent at a shop. They just rolled it for me. Left it a little big because I can just pull it in with a ratchet strap. It's only, I don't even think this is 1/8. I think it's like 90 thou 332. And yeah, I'm just gonna ratchet strap it in until I get a overlap and use some vice grips, clamp it in there. Let's check it out. So I got that lined up. Just for specs for this tank is gonna be about 58 gallons, 222 liters. So I'm gonna be tacking this up, and then we're gonna do some welding. Let's get through that. Alright, so I've got this welded up inside and out. Now I gotta do the a top and bottom cover. Try to save as much material here as I can, because I'm cheap. Okay, so what I'm gonna do with this too, when it comes to building stuff for me, sometimes I'm a little lazy if I just need it to work. So I'm actually gonna have this overhang. So I'm gonna leave the black line. So I'm just gonna be able to do an actual fillet on the outside of this. And that's just gonna make it quicker and easy to weld up and to line up. If I tried to do like an actual like corner joint on that, like, and I'm cutting this with plasma by hand, so it's gonna be really hard to line that up and set it on top and tack it and TIG weld a nice little fillet. It would look nice, but this is the bottom. I don't care.
right, so my next step, I finally got these ordered in. And this is what my plumbing is going to come in and out of. So these are just aluminum weld-on bungs. I've got 1/2 inch, I've got 4 of these. I've got another one coming because I actually want a vent on the top because this isn't going to be a pressurized system. Just want it to breathe. Hope that's not going to be an issue. So one's going to be, the top one's going to be your out because your heat's going to rise. So that's going to be your hottest liquid in here coming out. It's going to go in through the floor. My in, it's going to come through the bottom, of course. So I don't know how low I want it. Maybe right about there. And then my element, I also want that somewhat at the bottom. So somewhere's around there. I also have another one of these I'm going to put in the middle as a backup. I'm not going to use it. I bought 2 heating elements, and in case one goes bad, I can swap into the next one. And then I don't have to drain the tank and replace it. I can just swap to that one, hopefully, in theory. Now, speaking of draining, I'm gonna have another one close to the bottom so I can drain as much stuff out as I can, as much water. I don't know if I'm gonna put a glycol mix in this or not. I'm gonna try to figure that out, what the best is. So that's 1, 2, 3, and what was the other one? Oh, I've got a sight glass. So I want a sight glass somewhere up here too, so I can visually look at the level of the water. So that's going to be my level. So of course, if my out is there, I want my water to be, somewhere up here, and I'm not going to fill it right to the top. Yeah, and I think that will be good. I'm going to mark these out, position them where I want them, drill them, TIG weld them in. All right. There we go. That wasn't too bad. These holes I had kind of ream out with the deburring tool a little bit to get them in there, but everything went in good, welded good. I'll show you some welds. So next step, my tap is in. I got to go get it. I have to re-tap these because these are actually a NPT, National Pipe Thread, and they're a tapered thread. Hot water tank elements, they're National Pipe Straight or mechanical. So I have to tap those out to straight. And here are my elements I'm going to be using. So I've got 2 4,500 watt heating elements. They're gonna go in there, thread in. After I tap it, I notice too when welding these, I usually always have to run a tap through it because aluminum just warps and bows. So I'm gonna have to run a tap, the 1/2 inch tap, and then the 1 inch pipe straight tap through those ones. Then I can get those in there, get my fittings in. I have my circulation pump, which is gonna go up top here. So it's gonna push through my floor. This is the other thing. I don't know if I have to run pumps in tandem, like one out and one in. I'm gonna figure that out when the time comes. So yeah, I'll have to wait till I get the rest of the stuff and do the rest. All right, so I just tapped this when I finally got my National Pipe Straight tap. I tapped that. It was quite hard to start just because this is a taper thread. So it's hard to judge if you're getting started, like it wants to roll off. So what I'm gonna do with this one is just take my taper thread and just push it down a little bit so I have something to start with and know that I'm lined up. And I'm actually gonna use some cutting fluid on it because aluminum kind of galls up a little bit and just makes a cleaner cut, I guess. And then I'm just gonna take my 1/2-inch tap and just tap those down a little bit, not much, just until I know I have an even thread, because they do warp when you weld them, so they could be a little oblong or whatever. So that's what I'm gonna do here. There. Very nice. So yeah, definitely recommend using cutting oil. This one I didn't. It's kind of it's a rough cut. I didn't mess up any of the threads, but this one's like right, nice and shiny. So did that. Let's test that out. There. All right, so I just got done cleaning this. I just used some dish soap, just try to get the there's some grime in there and some metal chips. So I just want to get all that out so it didn't ruin a pump, and just to reduce buildup and scale in this mold. I don't know what could grow in that. I've been looking, and I see you can get water boiler treatment solutions to add to your water to prevent corrosion and buildup. So I think I'll add that too. Now, my next step is I have to figure out how to mount my thermostat. Now, as you see, I have a curved tank, and this thermostat wants to touch that, but mount on these little tabs. And I'm not drilling this tank and putting studs through it. So what I'm going to do is I have a piece of scrap 3/8 aluminum. And that just fits under there. So what I'm going to do is drill a hole through this so that this sets into, and then I'm going to drill holes and tap them so that I can mount this in, and this will go through that and touch the tank. And then I'll take this piece and just tack it onto the tank. That's all I need. All right, I just finished making that, so that's simply just a little hole drilled in, some 3/8. Then I tapped it for whatever screws I could find, the smallest screws I had, and drill tap size for it. The other thing I did is I ground a little curve in it so that it fits on there a little bit better. And when I put my thermostat on, I've got a little gap under there that will make sure it's making contact with the actual tank. So that's gonna be good. So if I lift this up, you'll see that it actually protrudes out a little bit. to make sure that it will come in contact with the actual tank. So next step, I'm going to figure out how high I want this. I want it closer to the top of my water, and I'm simply just gonna put a couple tacks on it, and that will hold. Alright, here's all my fittings. I'm going to start throwing these on now, just as far as the outside, and then I'll plumb everything up on the final plumb up in the greenhouse, because it's pretty warm in there. So what I've got is everything's half inch pipe to half inch PEX. That's going to be my in and out for my pump. I've got my breather, that's half inch. Got my sight glass, that's half inch. And then my thermostat, I already showed you that. And then I'm putting in my heating elements. So we'll get started and start throwing all that stuff on. All right, so I just mocked everything up here. This is my 12 volt pump. It's actually for solar. It's 3.3 gallons per minute or 13 liters per minute. Max head 10.5, so I'm well within that. Max temp 212 Fahrenheit, 100 Celsius. So what I'm going to have here is a shut-off valve coming out, and then that's going to go to PEX again, and then I have a union. I got my direction marked on it. This is coming into the suction, and the reason why I did that, I didn't want this threaded right into there, because in case you hit it, I want some movement, so I'm going to have some PEX there. That's going to make it flexible and movable. And then coming out, I have half inch pipe female to PEX, and that's going to go straight to my in-floor heating. So that union's nice, so I can shut the water off, take this union off, and replace the pump if I have to. I can take the union off, thread this off, then thread my pump off, and I can easily replace it without losing too much water. Now, for the bottom, I'm doing something similar, just without the pump. So what I have is, as if this is on the bottom, I'm going to have another valve coming out to shut it off. Going to half inch pipe, going to my union, a nipple, and then back to PEX. And the reason why I'm doing that is in case I have to add another circulation pump, which I'm not sure. So I like to be safe rather than sorry. Instead of having to drain the whole tank and then add all this stuff in later, I'd rather have all this stuff in here. So I can shut it off, thread that union off, take this off, and simply put a new pump in it. So that's good there. And one thing I want to show off here, these heating elements came with this rubber gasket, and it's pushing out the sides of this hex here. So I'm going to see if I can find replacement, something maybe with like a copper crush washer or something a little more rigid than this rubber, because I don't trust that that's gonna hold. just realized I forgot my valves, so that's kind of an important thing that I really want. So all I'm doing, I cut that right in half and throw this in. And there's the tank in the greenhouse. I think that'll be good. I'm gonna have my pipe coming in from the back, so that's nice and out of the way. I'm gonna have a panel here for all my electrical to clean it up. Yeah, I think that's a good spot. There's not much room in here to do anything with anyways. I could do shelves, which I'd like to. And then right over here, I got plenty of room for seating. Alright, so as I said before, I got stuff all over me already. God. So, came with these very rubber silicone style gaskets, and I can't believe that they come with them originally. Like they smush out, and the hex on these is so small that it just smushes out on it. Can anyone tell me if this is normal? I don't get it. I don't trust it. So what I'm doing instead, which is probably stupid, but I'm gonna test it out. So I made just a little gasket out of Gasket Maker, the paper stuff, and then I'm adding some Formagasket Spec 2BR, and this stuff is very tacky. And the first time I already did one, haven't tested it yet, but I got stuff all over my hand, and it's the biggest pain to come off. So I'm putting gloves on this time. So I'm putting some on the outside and the inside of this. That's probably too much, but whatever. Push this up here. Oh yeah, good boy. I like to make a mess. Now what it says to do is let that sit, let it get tacky, and then install it. Alright, I waited a solid 15 minutes. I don't know if that's long enough, but forget. I've got some stuff there. I'm gonna wipe this off. Alright, here we go. There, let's hope that works. So, under further inspection, looking at these, one is obviously bigger, and I don't think that was from me stretching it. You can see I've got a good 1/16 of an inch around it, and it's almost the same with the diameter. The inside diameter is not as bad, but even the thickness is different. So I think, because this one didn't seem as bad, I still didn't trust it, but this one was smushing out and definitely not going to seal. So has anyone ran into that? Are these all right? Could I have used at least the smaller one? I don't know. Hopefully this works better. Alright, so what I did, I just have a funnel up here. Hindsight, I wish I had a vent here, because I have to slowly fill from there so to get the air out too. So as I'm filling it, just checking down here, and I've had this filled up too. There's a little sweat line, it's hard to see here, but it is above my first heating element with my homemade sealant and gasket. So that seems to be holding. It's been here for about an hour and a half. Got a nice little sweat here. And no leaks yet, so that's a very good sign. Next step's filling it the rest of the way, making sure it doesn't leak, and then once we start heating this tank up, that could also still introduce leaks, because as aluminum heats up, it expands, and there could be a little pinhole in there that
that may open up enough to leak, but we will find that out. I'm gonna fill the rest of the tank up to my sight glass line. Make sure I close that valve. Right now I'm venting out of that spot, which helps. And then I can hook my plumbing up, circulate a little bit. Well, I gotta get power down here first. One of these is 12 volt. The other one's gonna be my actual heating elements. So that's gonna be like 150 volt. And once I have all that hooked up, I can really test her out. So I'm excited to see how it is right now. I'm just building the frames to hold the solar panels, and we'll go back to you when everything's full and hopefully operational. So it's completely full now. You can see by my sight glass there. And the bottom's completely dry. I can't find a speck anywheres. These are completely dry, so my homemade gasket seemed to work. Everything's sealed up tight. I don't have a problem, so that is great. Honestly, it kind of surprises me that it actually worked out. Awesome. So here's my frame for my solar panel. These are 590 watt solar panels. I got it upside down right now just to mount all my brackets on. So I'm just going with 2-inch angle, 1/8 thick, and I think that's going to be really sturdy once these are bolted to the roof. You know, they're not going to wobble this way. It's going to have little angle tabs on each end, and that's going to bolt to my roofing. My tin roofing is a little different. It's like industrial stuff, so it's got a big raised edge, so that's what I have to bolt to sideways into. So that's what I'm doing, and I simply just bolted to their existing holes they have here. There's one there, and I kept it in a little bit. I'm not worried about this panel flexing in the wind, I don't think, so that's why I stepped them in a little bit. I don't have a great big distance in the middle that's gonna bow or warp or anything like that with wind. And then down here I extended it out. I'm gonna have another little angle tab here that bolts to my roof, and I just overhung that a little bit to raise it off the roof. And this is the bottom part that's gonna sit on the top of my roof. And I got a relatively flat roof, you'll see soon. That's why I have to angle this up so much. So each panel is going to have one of these. It's a lot of angle, quite expensive. It cost me like $500 for 5 lengths of it, which is wild for aluminum. But anyways, that's that. And I'm not going to show how I made these. I pitched my angle about how I think how low the sun or how high the sun's going to be in the winter, because that's my main determining factor, because this is going to be operational in the winter. In the summer I'm probably going to disconnect it, maybe use it for something else, I don't know, and just disconnect the power, not the panels. Right, here we go. We got them all hooked up, or not hooked up, but mounted to the roof. I'll just show you how I mounted them to this roof. These are the little angle iron brackets I made, and this is bolted to that, and the same thing back here, and then on all 4 corners. Putting weight on this corner, like, it is sturdy. Like, I'm pushing quite a bit right there, and it's not budging at all. So originally I was kind of concerned about wind since I had these propped up, but it's I have no worries about it now. Alright, so this is the first test day. Today's going to be partly cloudy, but we got a fair amount of sun here. It's about 10 a.m. and the sun is just starting to peek out. It's not at the optimal angle for my solar panels, but what we have, this is the problem that's going to be getting optimal power out of this. We're at 104.5 volts. This system's supposed to be, when the sun's directly on it, it's supposed to be 150 volts, and so that's going to be the optimal range to match your ohms with your heating element. So early morning, and if it's cloudy out, and at night, you're not gonna, or later in the evening when the sun's going down, you're not going to get the optimal power to properly match your heating element. But what I found so far, I have a little thermostat in here, and it was at this morning 18.3 degrees. It is now at 19.8. So already it's heating up. So it's working already. Alright, so it's now at 42.9. It is 2:07. So since I started measuring at 2:06 or 10:06, sorry, that's 4 hours, and it was at 20.3. So that's a pretty good temperature rise. And today's a pretty, it's a sunny day, but it's hazy. And so I'm not getting my max voltage I could be. It should be around 148, 150, somewhere around there. And this is kind of high right now. It's been dropping down to 100 volts, so I'm quite impressed that it's still working that good. So see, it's a little hazy out, so I'm not getting the full potential I could be. So I'm quite happy with that, how well this is working. If anyone's interested in my purpose of this is my greenhouse. Very well insulated, and I'm just trying to add a little bit of supplemental heat to it at night. So I just want to check this this pump out, see if it's pushing good enough or struggling. So I'm going to try to move that solar panel more directly in sunlight. So yeah, I'm not able to get water pushing through that. Alright, so after noticing that my pump wasn't pumping through the floor, I came to the realization, I should have realized this earlier, but there's probably a significant amount of air in the system that can't be pushed out with a simple small pump. So what I have here is I cut my line here, put a T in, put a valve, and then my PEX to pipe thread, 3/4 pipe thread, and then this fitting here is for a garden hose. So I'm going to be able to put my garden hose on here, turn it on, open that up. I'm going to put the same here, so that's going to be my vent. Put another garden hose that I have that it's like cut off, and I can put a bucket here where I can actually put a high flow water through it, and it should be able to push the air out. And then if I want, I can put the inlet on the top side, push the air out the rest of the way the other way, see if it helps. And I think that will work. And then the nice thing about it is I can shut these valves off. I can keep this one open, turn my pump on, and see if I'm actually moving fluid, because it sounds like this thing works, but it's not actually pushing. So it's nice to know that you're actually getting flow. So you can shut this off and then open this up and see the water's coming out, and you're like, okay, my pump's still working, it's just not cavitating. So that's good. So this is what I'm going to do now, hook that up there, and we'll push the air out and see if it all works.
As I was putting water through it, a significant amount of air came out.
So first I just started off making my own tank because this is a non-pressurized system. I didn't want to buy a water tank and then have to replace things anyways and not use certain things. So I decided to make my own tank and buy all the components for it. I just simply rolled a piece of 1/8, I believe it was. I went to a shop, got that rolled, welded it all together. First time, no leaks in it, so that's good. And then I bought some welding bungs for it, welded them in for my heating elements, and then I had to retap them because they came as a I believe they're 1 inch or 1.5 inch pipe thread, but the heating elements are a straight thread, so I had to retap them for a straight thread. And then I just bought some plumbing fittings, hooked them in, circulation pump. I do have a thermostat, a DC thermostat, which I don't have hooked up because it doesn't get that hot, because it goes in through the floor and the floor soaks it out really easy. So I'm not going to have an overheating problem at all. So when I first started this up, I believe it was sometime in mid-October. So October 12th it was, and at 9:30 a.m. it started out at 18.3 degrees Celsius. End of the day, it got up to 46 degrees, and around 3 o'clock that day it got a little hazy out, so I didn't get the full extent of the sun. But that's a pretty good difference. That's about 27.7 degrees Celsius difference from what it heated up. This is when I did not have it circulating through the floor. So my hottest temperature here, so that was the 12th, we had 13th, 14th, 15th, 16th, 17th, 19th. On the 19th it got up to 53.8 degrees Celsius. That's pretty warm. That was almost too hot to even put your hand on it for like an extended amount of time. If you pushed hard enough, it hurt. So and in between those days we had some rain, some mostly cloudy days, so heated up really good. And I think my highest temperature on this tank before I started circulating through the floor was 56 degrees. So that was about 138 Fahrenheit, I believe. So still not hot enough at that point to have a thermostat. I imagine if I had like 3 or 4 consecutive days, it would have overheated. But ever since I started putting circulating it through the floor, it soaks the heat out really good. So, and that's the idea, to try to create that thermal mass under here and allow that to radiate through the greenhouse at night for those cold nights. So again, at first I had a problem with the circulation pump. I thought I needed 2. I bought a second one and I don't believe I need it. So I have one on the outlet of this, and that pushes all the way through the floor. I forget how many feet I have of in-floor heating pipe. It's 1/2 inch, and it was quite a bit. I think it's like close to 150 feet. Now, I had to put T's in here with valves and hose fittings, so I would hook a hose up and another hose for a vent or a drain. I would shut it off from the tank, and then I would turn my water hose on, and I would push all the air out. And I had to do that a couple times to actually get all the air out. And I even swapped, and I'd first start pushing in here, venting out the bottom, and then I'd push in from here and vent out through the top hose. And I did eventually get all the air out, and it circulates completely fine. So I as far as the electrical goes, I still don't have it all prettied up. I want to put a box up here to keep everything protected, and have all my shut-offs there and stuff like that. So what I have is 3 solar panels on the roof that are 590 watts each, and they're around 48 nominal volts each. I hooked them up in series, so I'm getting, you know, close to 146, 150 volts. And then I had them come into a disconnect here and directly into my heating element. Now for my circulation pump, it is just a 12 volt. I had a max of like 20 volts, 20 some volts you could put into it. So my 100 watt solar panel is actually puts out like 18 volts or something like that. So it's well within, you'll see the longevity of it. And then I have that separate coming down here to a disconnect powering that. So as soon as the sun comes out, starts circulating through the floor, and the hot water starts heating up. I would almost like to put a control system in here so that it doesn't circulate to the floor until this reaches a certain temperature, like 20 degrees or something like that. So that's that. So now that it's circulating through the floor, we had a day here where we had full sun. And at 9:30, we started out at the tank at 17.8 degrees Celsius. And by 4:30, which is like when the sun's starting to go down at this time of year, this is November, it got up to 25.5 degrees Celsius. So a lot of that is going through the floor. So it's being absorbed into the floor, the heat. And then my in-floor heating, if you can see, I have little tubes going into the floor so I can see how warm the ground is getting at certain depths. So this is an 8-inch slab. I also did 2 sand batteries kind of like as a little tester, and if you see my videos, originally I had 3 posts here, so I could only dig 2 small sections and do a 4 by 4 by 2 feet deep of a sand battery, completely insulated, and the concrete's completely insulated, so they're just extra thermal mass to hold more heat into it. Now my floor on that day at 9:30 when the tank was 17.8 degrees, at the 2 foot mark, the deepest part in this sand battery, it was 10.4 Celsius, and 6 inches, or about just under the concrete slab, was 15. And at the end of the day, both of those got up to 16.8 and 16.2 degrees Celsius. So it did raise the temperature, which is good, and there's a lot of mass there, so it's really soaking in that temperature differential that this could have. So on those full sun days, I'm getting close to about 30 degrees of heating in this. And once the floor's circulating, you know, I'm only getting from 18 to 25, which is like 7 degrees difference. So that extra heat is being absorbed in the floor. So that is working. So as far as I'm concerned, it is working. And if you're just doing this system as, you know, supplemental heat for hot water in your house, I think that'd be a great idea. And that's something I'm kind of looking forward to maybe doing, is having a pre-warming tank in my house, because in the summer I'm not going to have to heat this, and those solar panels are just going to be wasting energy. So I'd like to put an extra tank in my house that's just solar powered. So it will preheat my water, and then that preheated water will go to my main tank that's being heated from the grid. And if I don't have sun, my grid heating hot water tank will operate as normal. And then when there's sun out, you know, I'll save a little bit of electricity since it's just sitting up there anyways, and just preheat a little bit and save some power. So yeah, I don't know how well this will work compared to last year. Last year I specifically wanted to see how well this greenhouse would do in the winter. It gets fairly cold around here. Like, most we'll get is like minus 25 Celsius. And my coldest temperature in this greenhouse last year was minus 6.8 Celsius, I believe it was. So it worked really good for not being heated at all, just with sun and thermal mass in here. And last year I also I built this really late. I didn't get this closed in until November, first week of November, and I just brought soil in around that time, so the soil was already cold, concrete was already cold, and I didn't have a thermal mass at all in here, and it still did that well. So hopefully this year I'll get a real representation of how well this does. So I'm really excited to see if this stays above zero at least, and then I can keep these crazy tomato plants and peppers and grow some other stuff in here all through winter, which would be really fun. It's nice coming down here in the winter when it's absolutely frigid, miserable cold outside, and it feels like it's summer in here. Yeah, so the temperature in here usually like overnight, it's this time of year in November where I'm at, it usually gets below zero, a couple degrees below 0 Celsius, and this stays in here about 10 degrees Celsius. And then during the day when the sun's out, this place heats up to 25 degrees, no problem, which is what it is right now. I was really impressed with how well this retained heat and stayed relatively warm. So this year I'm curious to see how well it does with adding some heat in here during the day. It didn't freeze in here until December 20th, I believe it was. It just dipped below zero. So that was quite impressive to me for not being heated at all. So I'm hoping this year with this tank, heating it up, I should be able to keep stuff alive, I hope. I don't know, because sometimes we do get frigid days and a long stretch of cloudy days. We can get up to 4 or 5 days without sun, so we'll see about that. I also might just add some supplemental heat from a propane furnace I have. I might duct it in through this window, which is just inside the garage here, just to keep it above that 0 degrees. So we'll see. Yeah, if you're curious to see how I made this greenhouse, go check that video out. It's just a little short video, and I really like it. The only thing I wish I did is I wish I stepped this out further, because the deck above this overhangs it a little bit, so in the summer I don't get much sunlight in here unless it's early morning and then like later at night. So I didn't get as good as growth in here as I could have, but that's hindsight. This is kind of like a little tester. I'd love to build a bigger one. Like if you watch those videos from Argopia on YouTube, he built a massive, like about a 40 by 60 greenhouse, and that's an absolute dream of mine. So I would love to do that then. So this is just seeing how well this works in my climate, on a smaller scale. Of course, a larger scale will have more thermal mass and should retain heat overnight better. So we'll see how well that does. Stay tuned, subscribe if you want to. I'll do an update on this in January, February to show how well this actually did. And if I have to next year, I may add another section of solar panels, because I have 2 heating elements here and I only have 1 hooked up. So I will do that. I don't know if I've mentioned the electrical part in it. There's another video on YouTube talking about the ohms of resistance you need for a heating element. And when it comes to solar power, you need to match your solar panel's resistance to your heating element resistance. So these heating elements, wrote them down here, they're about 12 ohms of resistance, and my solar system is about that. This guy has a calculator online. I'll try to leave a link for that. And he's got a Excel spreadsheet where you can type in your solar panel wattage, the amps on it, your voltage, if you're hooking them up in series or parallel, and then that will calculate which resistance of heating element you need. And then also he has an Amazon link for heating elements. So thanks for watching the video. Stay tuned, subscribe, and check out my other videos. Thanks for watching.